Hi, I'm Diya Harish, registration number 19MIA1107, studying at VIT Chennai, and now we'll be executing code for Project 1 of NAND2TETRIS. Here our task is to build the following 15 gates using the given NAND gate, and for this we have to install a software from the official website of NAND2TETRIS, which is this one, NAND2TETRIS.org. From the software section there is a link for downloading it. This is the link. Download the NAND2TETRIS software suite. By clicking on it, a zip file will be downloaded in the system. Make sure you have a Java compiler, else it won't be working. After the zip file is downloaded, you have to extract all the files, and this file will be displayed. By clicking on it, you have two sections, project and tools. On the tools section, you have to open a Windows batch file called hardware simulator. Hardware simulator is the interface of the software with which we are going to build the following gates. So here is our given NAND gate. This is the logic gate and this is the truth table. NAND gate is the opposite of AND gate. From the truth table, it is clear that output is 0 only when both the inputs are 1. So now let's check this by using the hardware simulator. In the hardware simulator, this button is for loading the chip, this is for loading the script, and this column all the inputs will be displayed, and this column all the outputs will be displayed. HDL column shows our program code. This button is used for running the code. So now let's load the chip for the first gate, which is the NOT. I'll have to load the script now. Here is my NAND.TST, and also loading the script has an extension called .tst, and loading the chip has an extension called .hdl. So this yellow line shows which line of the code is getting executed. If the yellow line stops in the middle, it means our program code has some error. Now let me check it by running. It has completed successfully. So now I'll check my output. Here is my output. Now I compare it with my truth table. Both are correct, which means my program code is correct. So I'll proceed to the next one. Next one is my AND gate. AND gate have two NAND gates. This is the expression for it. Q is equal to A dot B. Let us check using hardware simulator. I'm loading the chip for AND gate. This is the script. Two inputs with a single output. Here is my code. I run it now. Yellow line is going smoothly, which means there is no error. Now I can check for my output. Here is my output. Comparing with truth table is also matches with my output, so it is correct. Now I'll go check for my OR gate. My OR gate requires 3 NAND gates. This is the expression Q is equal to A plus B. I'm loading the chip for OR gate. This is my script. 2 inputs with a single output. I run the code now. It has completed successfully. Here is my output. I compare, it is correct. So I can proceed to the next, which is the XOR gate. XOR gate requires 4 NAND gates, and here is the expression for it. I'll check it now whether it's correct. XOR gate. I loaded the chip. Now I load the script for XOR gate. There are 2 inputs with a single output, and here is my code. Now I run the program. It has completed execution without any error, so I can check my output now. Comparison is also correct. So our next logic gate is MUX. The difference between MUX and the other normal gate is that MUX involves 2 inputs with a single selector and a single output. This is the expression for the MUX gate. We'll check it now. mux.hdl and mux.tst. As I told earlier, there are two inputs with a selector. SCL represents selector and a single output. Now I run it. Completed successfully. This is my output. Comparing with truth table, both are correct. So I can proceed to the next. Next one is the demux. Demux means a single output with a selector and there are two outputs. In mux we had two inputs, so just the opposite for the demux, we have two outputs with a single input and a selector. We'll check for the demux now. I load the script for demux. Single input and a selector and two outputs. Running it. Yellow line is going smoothly without any error. Completed. So here is my output, input, selector and two outputs. Comparing is also correct. So I can proceed to the next one. Next one we have the 16-bit variance. This NOT 16 and 16 or 16 and mux 16. These are the normal gate, but there is a 16 bitwise operation. All other concepts are same for the normal gates except that it has a 16 bitwise operation. So now first we'll check for the NOT 16. I load the chip for NOT 16. I load the script for NOT 16. A single 16 bitwise input and a single 16 bitwise output, and here is my code. It has completed execution. Here is my output. Comparison is also correct. So my code is correct. Next is AND 16. AND 16 is same as the AND gate but a 16 bitwise operation. Two inputs with 16 bit and a single output with a 16 bit. I load the script now. AND 16. I'll run the code. Successful. This is my output. Comparison is also correct. I'll proceed to the next, which is our OR 16. That is OR gate with 16 bitwise operation. I load the chip for OR gate, OR 16. I load the script for OR 16. See here, two 16 bitwise input and a single 16 bitwise output. Now I run it. Completed successfully. So this is my output and my comparison is also correct. So we did OR 16 and next is mux 16. It is the mux gate with 16 bitwise operation. We'll check it now. I load the chip for mux 16. I load the script for mux 16. As you can see, there are two 16 bitwise inputs with a selector and a single 16 bitwise output. Now I'll run it. Completed execution. So here is my output. I compared it, both are correct. So 16-bit variance building the gates is over. Now we have the multi-variance, that is OR 8-way mux 4-way 16, mux 8-way 16, demux 4-way and demux 8-way. First we'll check for the OR 8-way. I load the chip for OR 8-way. Now I load the script for OR 8-way. There is a single 8-bit input and an output. That is called OR 8-way. Completed successfully. This is my output. Comparison is also correct. Now we'll check for the mux 4-way 16. Here is my script of mux 4-way 16. So there are 4 16-bitwise input with the selector and a single 16-bitwise output. Now I am running it. No errors. Here is my output. Comparison is also correct. I shall proceed to the next one, which is mux 8-way 16. I load the chip for mux 8-way 16. Now I load the script for mux 8-way 16. So there are 8 16-bitwise input with the selector and a single 16-bitwise output. So now I run the program. There is no error. So now I'll go to check my output. This is my output. I compare it. So I shall go to the next one since my code is correct. Next is demux 4-way. Demux is actually the opposite of the mux gate. So it involves a single input with a selector and 4 outputs. Now I'll run it. It has passed execution successfully. Here is my output. Compared it, it is also correct. So I can go to the next one, which is demux 8-way. I loaded the chip for demux 8-way and I loaded the script for demux 8-way. It has a single input with the selector and 8 number of outputs. Running it. Yellow line is going smoothly. It seems there is no error. There is no error. It has passed execution successfully. So here is my output. Compared it with truth table, both are correct. So my task of building the 15 gates is successful. Thank you for watching my video. Hope you have a great day.